Here we have population for 5 years from year 0 and to year 4, and also that's 5 time periods. So for every time period, it's equivalent to 1 year. I want you to use a logistic model to project the population of year 10, and that's also the population of the time period 10. So to use this, I have to first compute for the growth rates. So for the first 2 years or 2 time period from time period 0 to 1, I have my time period 0 population 300 and the next time period population 500, and the difference in that 1 year is 200. So I have the increment 200 divided by the previous population, that's 300. And therefore the growth rates between time period 0 and 1 is 0.67. That's 500 minus 300, that's 200, divided by previous population 300, that's 0.67. So similarly, for the next time period, from period 1 to period 2, the population grew by 150. So the increment is 150 divided by the previous population 500, and the growth rate is 0.30. From time periods 2 to 3, population grew from 650 to 750, the increment is 100. 100 divided by the previous population 650, that is a growth rate. From time period 2 to time period 3, that's 0.15. Similarly, I have the growth rate computed for time period 3 to time period 4. So the increment is 50. That's 800 minus 750 and the growth rate is 50 divided by 750, the previous population, and the growth rate is 0.07. And now we can have the information, for growth rates as related to the previous population. So for the first growth rate, it's 0.67. For this 0.67, the previous population is 300. And then similarly for the second growth rate, 0.30. So it's a growth rate from period 1 to period 2, and the previous population is a population for period 1, that's 500. And the next growth rate is 0.15, and then the previous population is 650, and the next one is 0.07, the previous population is 750. And now you can graph the growth rates in relation to the previous population to make decisions about whether logistic model is a good choice for this specific case study. So to do so, I will do the graph like this. So the horizontal line here is growth rates, and the vertical line is a level of previous population. So if you look at the first set of information, so I have growth rates 0.67 and then corresponding to the previous population of 300. So on the horizontal line, I look at 0.67 is here, and then on the vertical line, I look the previous population at 300 is here, and therefore the first data is here, it corresponding to growth rate of 0.67 and also previous population of 300. Similarly, for the second set of information, I have growth rate of 0.3 and the previous population of 500, and next record here and the next set of information here. So after you have graphed all those 4 sets of information, and you make decision about whether there's a linear relationship between growth rate and previous population, that means whether those 4 dots are located on a line. And here I would say, yeah, it's not exactly a line, but it's about a line, and therefore the decision is that the logistic model fits in this specific case study. And now the next step is to find out the values of A and B for the logistic model, and then you can use the logistic model to make projection of time period Kn. So to do so, I will use this is a relation between the growth rate and the previous population. So growth rate at a specific time always equals A minus B times the previous population. So I will use the first record and the last record to find out the values of A and B. So if you use the first record, the growth rate is 0.67 and the previous population is 300, and the relation between those is the growth rate is a relation with the previous population in as presented here. So 0.67 equals A minus 300 times B. And similarly, for the last set of information, we have 0.07 equals A minus B times the Sorry, I'll restart again. So for the last set of information, I have the same relationship of 0.07 equals A minus B times the previous population, that's 750 for the growth rate of 0.07. Now you have two equations and you can solve for the two values that you don't know. So to do so, I will start with the first equation. I just rearrange the three elements a little bit to move 300 times b to another side, and by doing this you have to change the sign from negative to positive. So I will get A equals 0.67 plus 300 times b, and then I will replace this A equals 0.67 plus times 300b into the second equation. By doing so, you will get this 0.07 equals A will be replaced by 0.67 plus 300b, and then minus 750 times b. So in this new equation, you only have one unknown, that's b, and then you can do some easy manipulation of the equation, and then to put all the numbers on one side and all the things with b involved on another side. And by doing this, you have negative 450b equals 0.07 minus 0.67, and then you can rearrange it and you can solve for the value of b, that's 0.0017. If you find out the value of b, and then you can plug this value of b into this equation of A equals 0.67 plus 300b, and then you get the value of A, that's 1.07. And now you know the values of A and the values of B. Just plug those values into the logistic model, and then to use t equals 10 to find out the projection of time period Kn. As for the capacity is simply the ratio between A and B, that's 1.06 divided by 0.0017, that's 815.